Hello everyone, and welcome to Priority Queues with Binary Heaps lecture. So we're going to switch gears a bit and talk about priority queues with binary heaps, and later on we'll see how that relates to trees. So we discussed stacks, queues, and decks, and now we're going to talk about an important variation of a queue called a priority queue. So a priority queue acts like a queue in that you can dequeue or remove an item by removing it from the front. However, in a priority queue, the logical order of the items inside the queue are determined by their priority. So the highest priority items are at the front of the queue, and the lowest priority items are actually at the back. And then when you unqueue or enqueue, basically meaning adding an item to your queue, into that priority queue, the new item may actually move all the way to the front, depending on its priority. So the classic way to implement a priority queue is using a data structure called a binary heap. And the binary heap is going to allow us to both onqueue and dequeue, add and remove items from this priority queue on order of log n. So the binary heap has two common variations, the min heap, in which the smallest key is always at the front, and the max heap, in which the largest key value is always at the front. In this section and the next lecture, we're going to implement the min heap. Okay, so let's go ahead and get ready for the next lecture, where we're going to discuss the implementation, show some code throughout a presentation, and then you'll have a Jupyter notebook as a resource. So in the next lecture, you'll actually see a presentation, and you'll be able to refer to the code notebook. We're not actually going to live code it because there's a bit of an explanation to go through as far as what the binary heap is actually doing. All right, thanks, and I'll see you at the next lecture.